This is my first video talking about modding a 3D printer. I took this Ender 2 and adjusted it so I have a fixed print bed, and the cantilever is now moving in the Y axis at the same time carrying in the Z axis, and the nozzle is moving in the X axis. So everything is carried on directly on the main cantilever X, Y, and Z. And now I have a print bed that's fixed with this design. So to do this, I printed several parts, several components, redesigned, moved the print bed to a different location, and adjusted many things, which I'll be showing you in a few minutes. Every component that was necessary and the design of each component. These components will all be uploaded to Thingiverse, so you can download. If you have an Ender 2, you can do the same modding. And if you have a different printer, you can maybe learn from this modding to adapt it to any other printer you have. So the goal is to have a fixed bed, cantilever moving, and the Y-axis. So now, as you can see, the entire cantilever is moving the Y-axis, then moves in the Z-axis, and finally the extruder moves in the X-axis. So now, as you can see, the entire cantilever is moving the Y-axis, then moves in the Z-axis, and finally the extruder moves in the X-axis. So I will now disassemble my 3D printer and show you every component in details and different iterations from a few mistakes which led me to the final design. So for the top part of the 3D printer, nothing was adjusted. I kept it as it is. It's a complete module where you have the extruder driver, you have the X-axis driver and the sensor and the nozzle. So this remains as it is. It already has a long cable, which makes it easy to reposition and still allow it to move in the required distances to print an entire volume. So as you can see from another angle, this is the print bed. It's fixed. Doesn't move, maybe not sturdy enough yet, and this is the cantilever beam moving along the Y-axis, driven with the same motor for the Y-axis. Now the position sensor is placed here to reference to 0, and everything is carried on this component here that was designed to hold everything, and the print bed is also carried on another component, and the main axis on which everything moves has also been shifted to a new position, carried also by two important components that you can see here. This white component you can see here, and print bed on the green component. The reason the print bed is on another color component is because I'm using another polymer. So everything is printed from PLA except the print bed, because the temperature of the print bed will rise on an Ender 2. To print, let's say, PLA or something else, I needed a polymer that will not soften at 60 degrees. So I printed that green part from PETG, which will not soften at least until it reaches 90 or 100 degrees. To lift the print bed, I went through 3 designs, starting with this one. So I used the holes that are already in the base, in the plate of the Ender 2. And I lifted the print bed high enough so it can clear the new position, and so it will home at the right position I intended to home, and still allowing this to move 14 centimeters, which is the print area that the Ender 2 is expected to be able to work with, 14 by 14. So the problem with this one is that it wasn't high enough. I needed to still lift it slightly, and I needed to shift it closer to the main axis. So I reprinted it, and something that some engineers do, including me, is that I made a mistake. I shifted it excessively, a bit too much, a bit, like actually a few millimeters more than I needed, but this made it touch with the wheel and made it a bit not too sturdy. So it's still flexible, and the print bed was just wobbling a bit. So I designed the final version, which you see here. This is much more reinforced, has much more beams connecting to it, and even an under support that allows it not to bend, not to flex at all. An extra part that makes it easier for me to detach and combine again, or makes it easy to change the type of the print bed, put a different type. So this is like a modular system that allows me to exchange the print bed easily. So the main component in this design, which was actually the most challenging one, is the component that carries the motors, the axis, and at the same time attaches to the belt and the motor that drives it. So this component is tricky because it's important to keep everything compact and still allow it to move the 14 centimeters needed. So I started first with the design where I would carry the 3 wheels. So the 3 wheels go in here and these would attach here. But this lifted the axis too much. So it was too high and this wasn't stiff enough. So it was bending and moving. And I forgot to add elements to connect the belt, which drives it. So I printed an additional part, combined it here so I can connect the belt to it to drive it. So this was just one of the learning phases. Then I lowered the system by placing the motor adjacent to the axis. So I placed the motor on one side with the axis, and on the other side I placed the wheels. This made it stiffer, much more compact, but at the same time made it kind of longer. So it wasn't able to move 14 centimeters anymore. It was moving about 11 centimeters. So the final decision or solution was to kind of bring the motors behind the wheel, which sounds easy, but it's not that easy because you need screws to attach the axis. And at the same time, you need 3 other screws to attach the wheels. And you don't want them to touch. You need some space between the axis with the motor and the screws for the wheels. So I designed this part, which has 2 levels, 2 layers. I think the camera can pick it up, yeah. So in this case, in the first layer, I had the wheels connected, the 3 wheels. And I added those large holes you see to insert the screws for the axis. So these are the screws for the axis, and these are the 3 screws for the motors. The problem with this is the way I designed it was supposed to print it in this orientation, upward. And when I attached the wheels, and there was a lot of tension here, you can see here there's a crack that formed, and that's because the layer orientation of the print. It wasn't easy to adjust this, so I needed to redesign it in a way that I can print it in this direction, so that all the layers are in the same orientation as the main plate that carries the tension from the wheels. And the rest has to be designed in a way that doesn't need much support. And I tried to optimize it to keep it lightweight and to keep it printable. So this was one of the main challenges in this design. And I'll show you without disassembling yet the final design, and then I'll disassemble it and show you the final printed version. So this was the final component. As you can see here, there are those 3 wheels that attach mainly to the aluminum rail, and they take a lot of tension here in between. That's why this is printed in this orientation, so that the layers are complete continuous and there's no delamination. But at the same time, you see from this side, there's a certain distance between the base plate and the second layer where the beam is. But that's because some additional screws are needed in between, and there's that space needed. So those were added, and this is the bottom side. It was optimized to be printed quickly and to remain stiff enough in this approach. And here you can see at the sides those added ears, so we can hook the belt and so we can drive it. It's very simple. You just insert from here and you release it. Now the final component that I needed to design was needed so I can lift the main rail. So this is usually So the final component that was needed was the main rail to be positioned at the right place and lifted so that the mechanism can fit behind it and move freely without touching any fixed spot. And to lift this, I started with again using the base of the Ender 2, lifting up with the simplest part possible. So this used just the long screws and was attached from here under the part. Of course, this wasn't sturdy enough and was actually rotating, so I needed to improve the design. Use the hooks part of the printer. So I designed this component. So you can see here these V slots go through here with the screw, and from the top there's holes for the aluminum extrusion, and it is reinforced by a 45-degree beam. This was good enough, but I still needed to shift the base slightly further and still make it a bit stiffer, and that's why I designed the final version, which you can see here. So these were the final version, with extra beams of reinforcement and an extra length, so which gave me from the top 3 screws to attach to and a much stiffer assembly. So I hope you found this quick presentation interesting of the modeling of Ender 2. This allowed me to learn a few things about design, learn a few things about the mechanism and how things fit together in a 3D printer. And I also learned some new things on how to improve the parts so they can print better, and how I can attach them in a way that are stiffer while everything is made from 3D printed components. And I've also tested the printer. I've printed several parts with this new setup, and I'm already working on the next step, which is to mod a second Ender 2 and combine them to print together. I guess you already know there are already printers in the market that have 2 extruders independently moving. So that allows them to print 2 components, but they only can print kind of a mirror component, as they are moving in the Y direction at the same time and they are at the same Z height. So what I'm trying to do is to have 2 independent cantilevers. Each moves in a different time on the Y axis, at Z axis, X axis. So they can be printing at different positions on the same component. Or they could be printing 2 very different components at the same time. Of course, 2 different components at the same time has no real function. You just get 2 printers and you print 2 components. But the point of this is so I can print 1 large part with 2 nozzles depositing independently. So I can accelerate the print, and I can at the same time print 2 different materials that are bonded in the way the layers are deposited. And I will show you more details on that in my blog article, which will be in the links below. I hope you enjoyed this video. Let me know if you have any comments on what I have done, if you have any suggestions of what interesting things we can do with such printers, and what will be another thing to do to an Ender 2 printer, or how we can make it work better.